Welcome. This video focuses on problem solving via search. So, computers aren't good at the kind of problem solving that people generally rely on. The technique of looking for high-level patterns and using those to guide where we go. What computers are good at is low-level calculations. So one technique for computer problem solving is to try and reduce the problem, or at least parts of the problem, to search, to exploring numerically different possibilities. So we're going to explore this graph, and we're going to try and find a path through this graph. The most straightforward way to interpret this would be that these nodes, these 8 nodes, represent 8 towns. And the edges, the lines between them, represent roads, and say the numbers are the number of minutes to travel that road. And we want to find the best path from one city to another. Right. Now this technique could apply to innumerable different situations, basically anything where we can reduce the problem to discrete states, and we can think of transforming the world or our position from one discrete state to another, and we can assign either costs or values to those states. And thus we can orient the problem towards finding a way to get to a particular state with a minimum cost, or given a number of moves, try to maximize the value we obtain. But for our problem, we're going to try and get from city number 1 to city number 6. So, what we know for sure is that we're in town number 1. The rules of the game are going to be we don't know that we're in the right town until we actually arrive at 6. So just because we happen to see 6 out there doesn't mean we know that's where we have to go. We also have no way of looking beyond kind of where we've already explored. So initially, from node number 1, what I can see is that there's a town over here that's 35 minutes away, and a town over here, number 2, that's 50 minutes away. So, we will start with town number 1. And town number 1 costs 0 minutes. I'm already there. Where can I go from town number 1? I can go to town number 3. And town number 3, I can see by the signposts, costs 35 for me to get to. Town number 2, well, I can get there as well, and that costs me 50. Okay, so now I've got 2 new possibilities to explore. I could either try going to town 3 and see where that gets me, or I could go to town 2 and see where that gets me. For all I know, one of these 2 could be the town I'm trying to get to. Remember, I won't know until I'm actually there. So, given that, my best bet is I probably want to explore this one first. I want to always take the path that looks like it might be the shortest one. So I'll go to town 3 and see where I can get to. Alright, so I go to town 3, I realize that's not where I want to be. And where could I go to town 3? Well, I could go back to 1, or I could go off to location 0, town 0. Alright. I can assign each of those a cost. So to get back to town 1, I'd spend 35 minutes and 35 minutes. So that'd be 70 minutes. To get to town 0, I'd spend 35 plus 100, so 135. Now, going back to town 1 doesn't make a whole lot of sense. If I'm planning my trip, I would never do this because I already know I started in town 1. I can get there in 0 minutes. So I could prune that off this tree that I'm developing of possible routes because that path is never going to make sense. So now, kind of what I know is I could go from 1 to 3 and that wasn't it, but then I could go explore this town. Or I could go from 1 to 2. And right now, this looks like the better bet. It's got a cost of only 50 minutes of travel. So from town 2, I go there. Oh, wasn't what I'm looking for, but where can I get to now? Well, I can go to town 0. And this route takes me 50 plus 30 is 80 minutes of travel. Or I could go to town 5. Alright, and so 5, How long does 5 take me? Well, it's going to take me 50 plus 100, 150 minutes. All right, looking at what I've got so far, this route to town 0 is better than my old route to town 0. So that's a sign that I could prune that node of this tree. I will never want to go to 1, 3, then 0, because I could always just do this instead. And this is the better path. At this point, I can actually see that there's no good reason to go to 3. This path has kind of led to a bunch of dead ends that weren't very efficient. So now I know I'm going to restrict my search to these paths. Of the two, so far this one is the shortest one, so that's the one I'll work on next. Where can I go to from 0? Well, from 0, I can go to 3. I could go back to 2. Or I could go down to 4. Now, 3, I can already see is not going to work out very well for me, because I've spent 180 to get there, and I already know I can get to 3 and 35, so that's a dead end. Getting back to 2 isn't going to help. Right, I was at 2 in a cost of 50 minutes, so going up there in 80 and then coming back down 110, that doesn't beat what I already know for getting to 2. 4, however, that's a brand new path. This one might make sense. And it costs 80 to get to where I already am, plus 110 more. So that's 190 minutes. And at this point, the two next states I have to explore as well, I could go boom, boom, boom and get to 4, or I could go boom, boom and get to 5. And those are kind of my two choices. Right now, 5 looks like the most promising. So I'm going to explore that next. From 5, I could go back to 2. I already know that that's not going to work out well for me, because that's going to be 250 minutes to get there, and I already can get there in 50 minutes, so that's not even really an option. Or I could go to 6 or 7. All right. How long do those take? Well, it took 150 minutes to get to where I am, plus either 45 to get to 6, so that would be 195. Or 35 to get down to 7, so that'd be 185. Alright, so at this point I've got 3 live paths. Go to 4 in 190 minutes, go to 7 in 185, or go to 6 in 195. Now, even though we kind of know that I'm supposed to be getting to 6, remember, we don't know that that's the right location until we get there. So I've got to look at what I've got going, and getting to 7 is the cheapest route I've got so far, so I need to expand off that. Alright, where can I go to from 7? I can go to 4, or I can go to 6, or I can go back to 5. And pretty safe to say that going back to 5 is not going to be a smart move. Getting to node 4, I'm 185 in, plus 115 more, so this has got a cost of 300. Given that I can already get to node 4 in 190, that isn't going to make sense. Node 6, I'm 185 in to get to 7, plus 40 more, so that's going to be 225, which doesn't make sense because I've got a shorter path that gets me to 6. So it looks like 7 is a dead end. Didn't take me anywhere new or anywhere existing faster than I already knew. Alright, looking at what I got left, well, I've got to pick 4 or 6. Alright, let's go with 4. It's the shorter path. So where can I get to from 4? I can go back to 0, or I can go to down to 7. I'm 190 in, 110 back there, so that'd be 300 to get to node 0. I got to node 0 way back there at 80, so that one doesn't make sense. Node 7, 190 plus 115, 305. Well, I already have a better path to get to 7, so that's a dead end. So I pretty much ruled out going that way. So now the only path left to me is, okay, let's explore this 1, 2, 5, 6. 6, that is where I want to be. I go explore 6, realize that's my destination, and here's the best possible path from 1 to 2 to 5 to 6.